Hi, I'm Patty Betzing from Eastmont High School, and today we're going to continue on with our trig identities. We're going to be looking at product to sum and sum to product formulas. Our school calls them identities, so if I flip back and forth, that's why. So what we're going to do is we're going to look at the identities. I'm going to put them up here for you. Okay, so there's three of them. Now notice these are taking the products and writing them as either a sum or a difference. Technically a difference is just a sum with a negative, so it's truly the same thing. So we either have a sine of an angle, sine times a cosine, or two cosines. If you have a cosine times a sine, it's the same as this one. So take a second and get those copied down, and then we'll do a few examples. This is going to be a short lesson. Okay, so we are going to use our new identities. So notice they're giving me a product, and the instructions are asking me to convert it to a sum or difference and simplify if possible. Sometimes these simplify, sometimes they don't simplify much. So we're going to do as much as we can. So I see this as sine times cosine, so I look at my identities. I'm going to be using the second one. Like I forgot my bracket at the end, I'm sorry. Hopefully you caught that. You'll want to close that off because this half has to be distributed in. So I have 1/2 bracket sine of a minus b. So it's going to be 20 minus 70 plus the sine of a plus b. 20 plus 70. I'm going to switch to a different symbol. The sine of 20 plus 70. Okay. I can simplify if I can, so I can at least do the quantities in the parentheses. So I have the sine of negative 50 plus the sine of 90. Okay, so clean that up. And then I want to continue on. Now I look at this and I have this negative angle in here, and I don't really want that if I can help it. Remember, we have an identity that says if I have sine of negative theta, that's the same thing as negative sine of theta, because sine is an odd function. So on this one I can write it as 1/2 negative sine of 50 degrees. I don't have to have that negative on the angle. And the sine of 90 we know to be 1. So I'm going to go ahead and distribute in the 1/2, and I don't like to have a negative on the leading term if I can help it. So I'm going to change it to 1 minus sine of 50 all over 2. And that would be considered our simplest answer. If I wanted to go simpler than that, I would have to do a decimal approximation where I actually evaluate the sine of 50 using my calculator. So here's another one. This time I have variables in there instead of actual angle measurements, but I'm going to treat it the same. This time I have a cosine being multiplied by a cosine. So I'm going to I'm going to substitute in a and b into my formula. So I have 1/2 cosine of, and I'm going to do a minus b, so it's 3x minus 2x, plus the cosine of a plus b, which is going to be 3x plus 2x. I'm going to simplify as much as I can. So I have 1/2 cosine of x plus the cosine of 5x. I can't evaluate either of those because I don't know what x is, it's variable. But I can at least clear the parentheses and give my final answer as a fraction, cosine x plus cosine 5x all over 2. So when you see these, it's just a matter of deciding which formula you need to use and being very careful of setting your equation up correctly and substituting in the right way, and then solving. Okay. So we also have to be able to work the opposite direction. So if I have a sum or a difference, I want to be able to write it as a product. So these are the sum to product formulas or identities. Notice they involve some fractions here, so make sure you get those copied down carefully and correctly. Okay, so we are going to try to solve a problem where we're given a sum and we are going to convert it into a product and simplify. So if I notice, I'm using this one right here. So this is the formula I'm going to be using. I'm going to be filling that in. Okay, so we're going to try one of these problems where we convert from a sum into a product, and then we're going to simplify. So on this one, I have a sine of an angle plus the sine of an angle, in what I know. So 2 sine pi over 5 plus 3 pi over 10, all divided by 2, parenthesis, and then cosine of pi over 5 minus 3 pi over 10 all over 2. Okay. Now I need to clean up these fractions before I go any further. I could reduce here, but I like to just do that at the end. 2 sine, this is 2 pi over 10, so I end up with 5 pi over 10 divided by 2. And the cosine of, this is also 2 pi over 10. When I subtract, I get negative pi over 10 divided by 2. These are ugly looking fractions. I want to simplify those. So I have 2 sine, and this reduces down to 5 pi over 20, which I can reduce all the way down to pi over 4, which I'm going to do. And cosine of negative pi over 20. Now, on this one, I've already simplified this, so I'm just going to write it as pi over 4. I'm going to be able to evaluate this, which is nice. On this one, I have the cosine of a negative angle. So remember, you have that identity that says if you have the cosine of negative theta, it's equal to the cosine of positive theta, and the negative just goes away, and that's because the cosine is an even function. So I'm just going to write this as the cosine of pi over 20. Now I feel kind of done because it looks like the last one, but I actually know what the sine of pi over 4 is. So the sine of pi over 4 is radical 2 over 2, and then cosine of pi over 20. And then I can reduce, and I end up with radical 2 cosine pi over 20. And that would be simplified all the way. Okay. So let's try another one of those that's a little bit different. Here's one. Again, we want to write it as a product. So take a second and do this one, and then we can go over it together. So this is a difference, so I look at my formulas, and I'm using this one right here. I'm going to be using this last one that we wrote down. So I have negative 2 sine of a plus b, so I have theta plus 5 theta over 2 times the sine of a minus b, so I have theta minus 5 theta over 2. And I need to clean this up. So I have negative 2 sine of 6 theta over 2, which we're going to jump a little bit, and that's 3 theta. Hopefully that didn't lose anybody. And the sine of 0 minus 5 theta gives me negative 4 theta divided by 2 is negative 2 theta. Okay, now I don't know what theta is, so I can't simplify this, but I do have a negative angle, and similar to the last one we had, I know that I can pull that negative out, which is going to make this a positive. So I'm going to have 2 sine of 3 theta sine of 2 theta, and then that one would be simplified. You never want to leave a negative angle. There's always something you can do with that. You can either pull the negative out front if it's a sine, or you can just drop the negative if it's a cosine. So make sure that's something you always do when you're simplifying. Okay, here is the last one. This is verifying an identity or proving an identity. So we have that the sine of x plus the cosine of x is equal to radical 2 cosine x minus 4, the quantity x minus 4. So when I look at that, I have to decide which side I want to work with. And like I've said before, I tend to work with the most complicated side first. But to me, this looks like it's the most complicated, but I have no idea what I could possibly do with that thing. With this, I mean, I can at least turn this into a cosine, possibly by using cofunctions, maybe squaring something, I don't know, but I'm going to work with this side, okay? So what I'm going to do is I'm going to use a cofunction. And remember, when you're doing identities, you don't always know what to do first. So you kind of make a plan, you think of what options you've got, and you pick one and you try it. And if it doesn't work, you try another one. This one I know is going to work, but... So I'm going to write this as the cosine of pi over 2 minus x, that's that cofunction that we got yesterday, I think it was yesterday, plus the cosine of x, and I'm trying to show that that equals all of that. Okay. Now, what I'm going to do is now I have a sum that is on my list. Notice I didn't have one with sine and cosine, so I had to either have 2 sines or 2 cosines. So now at least I have 2 cosines. So I'm going to be using this identity right here. So I have 2, make sure I'm using the right one here, 2 cosine A plus B. So I'm going to be very careful. I'm actually going to keep my parentheses on here just so I make sure I do everything correct. Plus x over 2 and cosine of A minus B, so I have pi over 2 minus x all over 2. Okay. And then I'm going to clean up what I've got. So I've got 2 cosine. These x's are just going to cancel out because I have a negative and a positive. So I'll have pi over 2 divided by 2, which is going to give me, I drew a really big line there, pi over 4. And then I have cosine, and we'll clean up this side. And when I simplify this side, I get pi over 2 minus 2x over 2. Okay, it's a little sloppy there, sorry. And I'm not happy with how this looks. I'm going to clean that up a little bit more. So I have 2 cosine pi over 4, which I can evaluate. Cosine, this is pi over 4, and this reduces to x. So this is starting to look kind of like this, but not quite. Okay, I've got the sign opposite. So let's evaluate here and see what we get. The cosine of pi over 4 is radical 2 over 2. My 2's are going to reduce. So this is really close to what I want, but it's not quite there because this is backwards. I want x minus pi over 4, not pi over 4 minus x. So I have to think about what can I do to make this look like that. That's the only thing I need to change. So I'm going to just force it by pulling out a negative. I'm going to pull out a negative sign, which is going to change the sign of each of those, leaving me with x minus pi over 4, which is what I actually want. And then, since cosine is even, I know, remember that the cosine of negative theta is equal to the cosine of theta. So I can just drop this negative, leaving me with radical 2 cosine x minus pi over 4. And then I'm done with that one. So this is, if you have the same book the college uses, this is done a different way in the book, and I did it a different way. They're similar, but it just shows you that there's multiple ways to do these, and sometimes you've got to try several things before they work, and don't expect to always get it on the first try. In fact, usually you won't. As you get better at them, you'll know that this problem looks like something you've done in the past, but for a while, it's just guess and check. You try one, if it doesn't work, cross it out, you try something else. I suggest not erasing, because sometimes when something's not working, you end up going back to that method and you can just sort of pick up where you left off. But try something, kind of make a plan in advance, and then start working through it. If it's not doing what you think it should, you know, check your work, talk to a friend. Worst case, try something else. So good luck with these. I promise you they get easier the more you do. Have fun.